Good morning, students. How all of you are doing? The 10th and 12th board date sheets are out, and so you must be now busy in doing the practice. So, for your pre boards, I have also come with another series. This series consists of electricity chapter. So, let's start with it. Now, electricity is the study of charges. Now, there is one term called as static electricity. Static electricity is the study of charges at rest. Whereas dynamic electricity is study of charges in motion. Now, dynamic electricity is called as electric current that comes in our houses from the main line. So electric current is the flow of charges. You can say when there is a flow of charges from one point to another, you call it as electric current. So there are different terms. You can say flow of charges, then charges in motion or charges, moving charges. All this come under electricity. And one is the study of charges at rest. So in this chapter we will be studying electric current. Now before we move further, let's define how many types of charges are there. One is positive charge and another is negative charge. Their properties are positive charges repel each other. Positive or negative charges repel each other. However, positive charge attract negative charge. So the conclusion is, what is the conclusion that you can draw from this? That like charges repel each other. And unlike charges attract each other. This you have studied in earlier classes also. So plus plus would repel, minus minus would repel. Whereas plus minus or minus plus would attract each other. I think you have understood up till now what we have studied. Now, how do the motion of charges take place? So, motion of charges take place when there is a potential difference. Now, this term we will define later on, but at this moment you just remember that motion of charges take place when there is a potential difference across 2 points. Now, what are the examples? How do you know that what is potential difference? So basically you must have seen in a battery or a cell. What do you have in a battery or a cell? You have a plus and minus at its two ends. So this plus and minus is actually the potential difference that is created across the battery. So if you are asked that give an example where potential difference is created, so you can say that battery or cell has a potential difference at its end. One is plus and another is minus. So one end is having more potential as compared to another end. So this is our current when this battery is connected to wire. Wire is a conductor, so then electric current flows. So how does we studied that there are two types of charges? When they are at rest, that is static electricity. When they are in motion, we call it as electric current or dynamic electricity. Like charges repel each other, whereas unlike charges attract each other. Now, motion of charges take place when there is a potential difference, and how that potential difference is created, that is created with the help of chemicals, and it is battery or a cell where potential difference is created. So when you connect battery to a wire which is a conductor, then electric current flows. Now here the term comes out, conductor. So there are two types of materials, rather three types of materials you can say. Which we come across. One is the conductor. So metals are good conductor of electricity. Whereas non-metals are poor conductors. There are exceptions that you remember, such as graphite. Graphite is a good conductor. Which is non-metal. So one is conductor, then you have semiconductors. Now what are semiconductors? These are the, so example of conductors are metals, so you can say that aluminium, copper wires you have seen in your daily life. Aluminium wire is a conductor, good conductor. Then copper wire is also a good conductor. So these are few examples of conductors of electricity. Then you have semiconductors. Semiconductors is a class of material which conduct electricity. At a particular temperature. Okay, so when the temperature is increased, the conduction starts. However, if the temperature is low, there is no flow of electric charges. So semiconductors, you have examples like germanium, silicon. So these are few of the materials which are called as semiconductors. Then you have insulators. Insulators are the material which do not conduct electricity. So basically you are asked to wear your slippers while switching on the fan or switching on any heavy appliance. So the reason is that so that the charge do not flow through your body. You must remember that your body is also a very good conductor of electricity. So that's why human body is also a conductor of electricity. Now, material which do not conduct electricity are insulators. Examples come as rubber, plastic. So these are few of the materials which do not conduct electricity. Now we will come to electric current. Electric current is the flow of charge. This you already know now. So how you define electric current? First, the definition you should know. When the charges flow across the conductor of any cross-sectional area, when the charges flow across the conductor of any cross-sectional area, the amount of charging flowing the amount of charges flowing per unit time is called as electric current. So very important portion of that you must remember is that the definitions are very important part of your curriculum in this your board exams. Generally definitions are asked and there are some key words that needs to be remembered. Like here the key word is any cross sectional area. So this means that whether the wire is thin or the wire is thick, the definition doesn't depend upon the cross-sectional area. What is cross-sectional area? Like the wire is of cylindrical shape and its base or its ends are circular. This you all know that the ends are circular. Wire is a cylindrical shape with its ends circular. Now this area of the circle of any wire is called as cross-sectional area. Cross-sectional area. So the thickness of the wire, the current flowing in the wire is independent of the thickness of the wire. This is important in this definition. This keyword must be included while writing the definition. If you just write that the charge is flowing across the conductor, the amount of charge is flowing per unit time is called electric current, then your definition definitely the marks would be not given for not writing any cross-sectional area. So the current flowing is independent of the cross-sectional area. So I can write over here current flowing is independent of area or thickness of the wire. In a layman language you can say thickness of wire. So wire can be of any cross-sectional area. Okay, this is very important point while writing the definition. This keyword must be included, otherwise there would be cutting of marks. So the wire is of any cross-sectional area and the amount of charges flowing per unit time is called as electric current. Now I would give you a definition called as conventional direction of electric current. Conventional means earlier times when there was no research based on the charges, then how it was concluded that what should be the direction of electric current. So conventionally all of us knew only two types of charges. One is positive and one is negative. So conventional direction of electric charges was the flow of direction of flow of positive charge was considered to be the electric current. Okay, this was earlier. In earlier times, the conventional direction of electric current was considered to be the direction of flow of positive charges. However, when negative charges were discovered, now what are negative charges? You must have studied in, these are electrons. So now we know that it is actually the flow of electrons which constitute the flow of current. However, the direction of flow of positive charge is opposite to the direction of flow of negative charge. So you just remember at this point that conventional direction of electric current was considered to be the direction of flow of positive charge, because negative charges or electrons were not discovered at that time. So here in the definition we are just writing the amount of charges flowing per unit time is called as electric current. So if I denote, I, together, whenever definition is asked, together with the definition you must write the formula. So the symbol of current is I, charge, symbol of charges is Q, and for the time of flow you say that denoted by T. So we get the formula as I is equal to Q by T. This is the formula. Now when you are writing the definition, you must write the formula also together with it. So this is very important. Just don't write only the definition, write the formula also and the meaning of the variables. Here the variables are I, Q and T. So you must define or describe what is the meaning of I. I is the amount of electric current, Q is the amount of charge, and T is the time for which the electric current is flowing. So this is the complete definition of the electric current. Now here I would like to give you units also. What is the unit of Q? That is charge. The unit of charge is coulomb. Time is measured in seconds, which is SI unit. All these are SI units. So you're solving, while solving the numerical part, the SI unit are considered more. However, you can get some, in some cases you can get different SI unit, but while doing the definition you must consider the SI units, and I is ampere. So SI unit of current is ampere. SI unit, all these three are SI unit of current. So charge, what was the definition? Amount of charge flowing per unit time. So per unit means the time would come in the denominator and charge would come in the numerator. This you must always remember. Per unit time. Per means you have to divide with the time. Other definition is the rate of flow of electric charges across conductor of any cross-sectional area. So what is this? Again, whenever you compare anything with the time, like you say distance covered per unit time. So what is that called? That is called as speed. Speed is equal to distance upon time. Okay, speed is equal to distance upon time. So then you say that rate of distance covered. So but we don't define it like this. So here we would define it rate of flow of electric charge. So what is this rate? This rate signifies that we are comparing the the amount of charge with respect to time. So rate of flow of electric charges across conductor of any cross sectional area is called as electric current.